the screen visible?
Yes, sir.
Yes, sir.
राइट, चलिए मैं एक क्विक गो थ्रू करता हूँ जो लेक्चर मैंने आपसे शेयर किया है। इससे पहले हम ये डिफरेंट फॉर्म्स ऑफ एनर्जीज पर डिस्कस कर चुके हैं। जो दो मेजर फॉर्म्स हैं, एक मैक्रोस्कोपिक, सेकंड इज माइक्रोस्कोपिक। Right, so the total amount of energy of any substance or a system consists of these two major parts. One is macroscopic, the second one is microscopic. Energy के units we have already discussed, kilojoules or kilojoules per kilogram for a unit mass. Then if we multiply that energy with mass flow rate, then it becomes kilowatts. Mass flow rate क्यों use करते हैं? Because in every thermodynamic system there is a certain mass of the fluid which is continuously circulating in the entire system. So that's why we have to multiply this energy with m dot, right, to get the energy rate with respect to time, that is kilowatts, right, or BTU per hour or BTU per minute in English units. Then we have now discussed internal energy in more detail, right? The microscopic form of energy. So at microscopic level, what is happening? All the molecules or atoms, they may be translating. If it is gas or liquid, they may be rotating, they may be vibrating. So inside the molecule or at the atom, there are electrons, they are continuously moving. Then the nucleus itself may be spinning. So all these motion at molecular level. Because of these molecular level motion, we have energy in any system or a substance. So sum of all these energies at molecular level is known as internal energy, and that internal energy cannot be zero, because it can be zero only if the temperature of any substance is 0 Kelvin. So every substance whose temperature is above 0 Kelvin, it carries all these different forms of motion at molecular level, and that's why it has an energy inside it at molecular level. फिर हमने its molecular level पे जो energy है, इसके आगे further 3 types हैं. Internal energy जो various binding forces की वजह से. For example, if we supply energy to any substance, its temperature will rise, right? Because the binding forces between molecules, it is not bonding, it is binding forces. It is related to phase change, right? I think मैंने सब यहाँ पे discuss किया. Sensible energy क्या थी? जब phase change नहीं हो रहा, just उनकी जो motion है, motion of molecule increases and the temperature rises, that is known as sensible energy. ठीक है, internal energy के आगे 3 types हैं. एक मिनट में दूसरी स्लाइड ओपन करूं जिसमें डिटेल में एक्सप्लेन किया हुआ है. राइट, ये थी इंटरनल एनर्जी, डिफरेंट फॉर्म्स ऑफ मोशन, ये सब डिस्क्रिप्टिव फॉर्म में भी अवेलेबल है. देन इंटरनल एनर्जी हैज फर्दर 4 मेन टाइप्स. One is known as sensible energy, that is that part of internal energy which is related to kinetic energy of molecules, only kinetic energy of the molecules. So if we supply energy to any substance, its kinetic energy increases and its temperature rises, but its phase does not change. Its phase does not change, and also the chemical nature of the substance also do not change. Then the energy which we are supplying it is only changing its temperature, either increasing or decreasing. So that part of energy is known as sensible energy. Right? That part of internal energy is known as sensible energy. So internal energy आगे further types, and first one is sensible, right? So that energy, और फिर अगर आप further energy supply करें, so we know at certain temperature its phase also change. So why phase changes? Because these binding forces between molecules, they become weak, right? So that portion of internal energy which is responsible for the phase to change, for example, solid changes to liquid or liquid changes to gas, that portion of internal energy is known as latent energy. Latent means hidden, because during that energy transfer we cannot sense the change because of no temperature change. Because जब भी कोई phase change हो रहा है, temperature stays same, so we cannot sense this change. So that's why it is not sensible energy, it is latent energy or hidden energy. So that is the second type or second part of internal energy, which is related to phase change process. The third one is chemical energy. So internal energy, which is associated with the atomic bonds in a molecule. So whenever the bonds, not binding forces, it is the bonding forces. Whenever the bond of those molecules breaks and new molecules or new substances made, and during that part, the energy which is released is known as chemical energy. So in thermodynamics, the chemical reaction which we are dealing with or which we are interested is the combustion, because with the help of the combustion process, we extract energy from the fuels, right? So whenever the fuel reacts with the atmospheric air, its chemical energy is released. So that is the third form of internal energy, because that is also related to molecular level. So that is the third form of internal energy. The fourth form is related to the energy which is released when the nucleus of any atom or molecule is disturbed or is broken, or when the two nuclei are joined together. So the energy which is released due to the nuclear reaction, right, that part of internal energy is known as nuclear energy. So chemical energy kya hui? That energy which is related to the electronic configuration. Whenever there is a change in the electronic configuration, the energy associated with that part is known as chemical energy, and the energy which is associated with the change in the nucleus of any atom or molecule is known as nuclear energy. ठीक है, अब किसी भी सब्सटेंस में फॉर ऑल दीज डिफरेंट फॉर्म्स ऑफ इंटरनल एनर्जीज आर अवेलेबल. सो अगर तो फेस चेंज हो रहा है देन दैट पार्ट ऑफ एनर्जी इज लेटेंट एनर्जी. अगर फेस चेंज नहीं हो रहा, सिर्फ टेम्परेचर चेंज हो रहा है, देन इट इज सेंसिबल एनर्जी. If there is some chemical reaction going on and the nature of the substance itself changes, then it is known as chemical energy. And if there is a change at the nucleus level, then the energy which is released or absorbed is known as nuclear energy. So ये डिटेल में हमने डिस्कस कर लिया था इन दी रिकॉर्डेड लेक्चर. सो फर्दर आगे चलता हूँ. सो दी आगे फर्दर हम इस एनर्जी को, इंटरनल एनर्जी को फर्दर हम डिस्कस कर रहे हैं. टोटल एनर्जी ऑफ अ सिस्टम can be contained or stored in a system. So that is known as static forms of energy. For example, we have some substance. This substance में इस वक्त internal energy भी है, but there is no there is no kinetic or potential energy. The macroscopic form of energies are zero. It is lying on any surface. Velocity is zero. So potential energy is zero, kinetic energy is zero, but it has internal energy in it. So in that case, it is also known as static form of energy, because that energy is contained in that substance or a system, and it is not leaving the system. Nothing is entering into the system, nothing is leaving the system. So under this condition, the energy which this system has is known as static form of energy. But whenever this substance, for example, it moves with a certain velocity, or it gains height, right, with this reference, or its phase is changed. So it means it is absorbing energy or it is releasing energy, because when it will be changing from solid to liquid, so it would be absorbing energy. When it is changing from liquid to solid, it would be releasing energy. So now the energies are crossing the system boundary. So in that case, it is also known as dynamic forms of energies or energy interactions with the surroundings. Right? Dynamic forms of energy, वो आपको कहाँ visualize कर सकते हैं? Only at the system boundary. ठीक है, सिस्टम की बाउंड्री के क्रॉस कोई एनर्जी क्रॉस हो रही है, जिसकी वजह से दैट वी कैन सी दैट सम एनर्जी इज एंटरिंग और लीविंग द सिस्टम, एंड दैट्स व्हाई इट इज नोन एज डायनामिक फॉर्म ऑफ एनर्जी. क्लोज्ड सिस्टम में, क्लोज सिस्टम मीन्स नो मास एंटरिंग और लीविंग. फॉर एग्जांपल, दिस इज अ सिस्टम जिसका मास फिक्स है, मास इज कांस्टेंट, फिक्स्ड, closed system. So now the energy can enter or leave such a system only in the form of either heat or work. Okay, mass to zero, no mass is entering or leaving the system. So जो हमारी एग्जांपल थी स्टीम पावर प्लांट की, उसमें here boiler, turbine, condenser and a pump. So this example may be when we see this system, ये जो system की boundary है, this one. इस system के cross there is no mass entering or leaving, right? Only energy is crossing the system boundary. Okay, so now read that sentence again. Only two forms of energy interactions associated with a closed system. कौन सी? Heat transfer या work. There is no mass transfer. So here you see an example. Closed system. ये जो यहाँ मैंने draw किया. This is a closed system. Only interaction is heat transfer. यहाँ पे heat transfer हो रही है, यहाँ पे work transfer हो रहा है. So these are the dynamic forms of energy. This heat entering, work leaving, heat leaving, or work entering. All these are dynamic forms of energy. In a closed system, the only dynamic forms of energy involved are heat transfer, boiler में या condenser में, या work transfer in the pump or in the turbine. Heat transfer कब होती है? Whenever there is a energy transfer only due to temperature difference. So that form of energy is known as heat transfer. The energy which is crossing the system boundary only due to some dynamic movement or motion is known as work transfer. Okay. So kinetic energy of an object is an organized form of energy. Here you can see the example. Recorded lecture भी मैंने इसको separately explain किया था. So here you see water contained in this vessel or reservoir. So when this water, if you place this wheel inside this static water, although there is molecular motion, but we all know this wheel will not rotate in this static water because the molecules are moving randomly. So maybe the total number of molecules which are trying to rotate this wheel in anti-clockwise direction is equal to the number of molecules which are trying to rotate it in clockwise direction. So that's why, although there is energy at molecular level, but that energy is not useful because we cannot convert it into work. So what we have to do, we have to install such a mechanism so that all the molecules are moving in one particular direction. So now this microscopic level energy is converted into macroscopic level of energy. And now it is useful. That can be converted into work. So now the wheel can rotate in this situation, but not in this situation, because that was the molecular random motion. That was also kinetic energy of the molecule. Kinetic energy of the molecules are involved here, but here the kinetic energy of molecules in one particular direction. यहाँ पे random थी, right? So in general we use the term kinetic energy for macroscopic movement of any substance. जो molecular level पे kinetic energy है, that is known as internal energy, not kinetic. We do not use the term kinetic energy for molecular motion. So whenever all these molecules are moving in one particular direction, only then we can extract some useful output, and that is known as macroscopic kinetic energy, which will make this wheel to run or to rotate, not this wheel. So यही thermodynamics का purpose है. Purpose क्या है? We want to develop such systems in which we are actually creating or converting this microscopic level kinetic energy of many molecules into macroscopic kinetic energy of molecules. In other words, we are actually trying to convert this disorganized form of energy into an organized form of energy. So here you can see all the molecules are moving in one particular direction. So that is the organized form of energy. So this disorganized form of energy is actually heat, and this organized form of energy is known as work. आगे चलते हैं. Now we shall discuss what is mechanical energy. We already now know that there are different forms of energies: macroscopic, microscopic. Macroscopic में we have discussed. We know that the common forms of macroscopic forms of energies are kinetic and potential. Microscopic में अभी तक हमने study किया internal energy. So मैकेनिकल एनर्जी अभी उसी में एग्जांपल्स की हेल्प से एक्सप्लेन करता हूँ. Here is our example. So in this system, what you see that in the pump and in the turbines, there is no heat energy involved in case of pump and in case of turbine. There is no heat energy or internal energy is involved. That is only work, or here is the motion of the fluid through the turbine and also through the pump, right? There is no thermal part. There is no change in internal energy of the system. इस pump में जो fluid in होता है, it is entering with certain energy in it, and we add energy to this form. So what this energy does, it raises its pressure, or maybe kinetic energy. Sorry, kinetic energy. And the third one is potential energy. Okay. Internal energy from inlet till outlet, because there is no change in temperature, because the liquid is flowing through this pump and its temperature does not change. और यही हम normally observe भी करते हैं कि पंप के इनलेट से लेके आउटलेट तक या तो प्रेशर में चेंज आ रहा है, या काइनेटिक एनर्जी में चेंज आ रहा है, या फिर पोटेंशियल एनर्जी में चेंज आ रहा है. बट देयर इज नो चेंज इन इंटरनल एनर्जी. वी डू नॉट see any change in temperature of the fluid. So it means in case of such system, only mechanical forms of energies are involved. So what are the mechanical energies? Either this work, or this pressure, or this kinetic energy, or this potential energy. Now let's see what is that term pressure energy. Now we are learning or trying to understand a new form of energy which is called pressure energy. अब मैं आपको explain करता हूँ what is meant by this. So here we have for example solid substance. इस solid substance को आपने एक vessel में रखा हुआ, ठीक है. इसी के साथ एक और vessel है जिसमें एक liquid substance है. Let's see another vessel in which we have gaseous substance, gas. ठीक. तीनों substances का जो temperature है, it is above 0 Kelvin, so it means all these have internal energy in it. इन तीनों में इस वक्त internal energy है. Molecular motion है, ठीक है. यहाँ पे vibratory है, यहाँ पे moving है, यहाँ पे बहुत ज़्यादा moving है available है in case of gases. Now, if I break those walls of that substance, then what will happen to solid, liquid, and gas? ये जो walls हैं, इन तीनों containers की आप इनको remove करें side से. So what you will observe, what will happen to solid? Will solid flow? Containers की side walls आपने remove कर दी. So what about the solid? Will they flow?
No, sir.
No, sir.
What about liquids and gases?
Yes, sir, they will flow.
Yes, sir.
They will be flowing, right? Internal energy तीनों में same थी, तीनों same temperature पे थे, but when you remove those walls, only liquids and gases, they will be flowing. So it means their molecules are actually exerting some energy on side wall, side or top, everywhere they are actually exerting some extra energy which is not present in case of solids. Solids में सिर्फ ये bottom पे है, that is because of gravitation, ठीक है. Sides पे या top पे, this vessel is not experiencing any force in case of solid. But in case of liquids and gases, जिनको in combined we say these are fluids. So it means fluids में एक और energy भी है, which we name it as pressure energy, because the walls of that vessel in which this liquid or gas is present, they will be experiencing an extra force which is exerted by that fluid, ठीक. और वही जो force है per unit area, we name it as pressure. सॉलिड्स के केस में साइड्स पे कोई नहीं है, सिर्फ बॉटम पे है, वो भी ओनली ड्यू टू इट्स वेट एंड ड्यू टू दिस ग्रेविटेशन. But liquids or gases may, because molecules are continuously moving around, so that part of energy we name it as pressure energy. But pressure energy कैसे, pressure के units क्या होते हैं? Newton per meter square. When I say it is energy, so then these are not the units of energy. So the pressure which is developed by this liquid and the pressure which is developed by this gas will be different, although both are at the same temperature, but the pressure which the side walls will experience due to the presence of this particular fluid will be different. So it means the property of that fluid needs to be incorporated. इसी pressure को अगर मैं divide कर दूं density of that substance, how dense that substance is, तो अब क्या units बने? Newton per meter square divided by kilograms per meter cube, or in other words, I can write it as meter cube per kilogram.
Newton meter per kg.
Right. So that is Newton meter per kg. So what is Newton meter per kg? What is Newton meter?
Energy per kg.
What is Newton meter?
Joule.
Joules. So now it is joules per kilogram. ठीक है. अब ये 1 किलोग्राम है या 10 किलोग्राम सब्सटेंस, उसको आप इससे मल्टीप्लाई करें, so you will get joules. ठीक है. और per unit mass के फॉर्म में joules per kilogram. So pressure itself is not the energy, but pressure divided by rho. Now it is energy of that fluid, whether it's liquid or gas. So internal energy तो है ही है उस substance में, plus उसमें एक extra energy है which we are naming it as pressure energy, and that is P over rho. This is small u, internal energy plus pressure energy, plus these are now the microscopic forms of energies. Okay, both internal energy and pressure energy. इस pressure energy को we also say it is flow energy, because इसी energy की वजह से this liquid or gas are actually flowing. ठीक है, जब gas या liquid flow नहीं कर रहा, even then they are exerting force side walls पे भी और all around, जिस भी container में ये liquid या gas है. Okay, so when it is moving, when the same gas or the liquid is moving, now it has pressure plus kinetic energy also, because now it is moving with certain velocity. All the molecules are moving in a particular direction, but still that gas or liquid is exerting force in every direction. Okay, a major portion of course in one particular direction है, but दूसरी दो directions में भी liquids are exerting some force. ठीक है. So a moving fluid will have both pressure energy plus kinetic energy. A static fluid will have only pressure energy. Internal energy to है ही है because of its temperature, because temperature is not 0 Kelvin. Solids के case में you have only U. There is no flow energy. There is no P over rho involved in case of solids. ठीक है, flow energy इसमें नहीं है. वो जो mechanics of materials में pressure पड़ते हैं वो that is because of its weight, जो कि bottom पे act कर रहा है. ठीक है, that pressure is different from the pressure energy which we are discussing here. That pressure energy is actually known as flow energy. ठीक है, the solids do not flow. Liquids and gases they flow. So that flow energy is known as pressure energy. So अब किसी भी substance में कौन-कौन सी energies होगी? Internal energy plus pressure energy plus kinetic half v square plus potential energy. ठीक है, ये मैक्रोस्कोपिक, ये पर यूनिट मास की फॉर्म है. किसी के साथ m नहीं लिखा हुआ, आप सबके साथ m को मल्टीप्लाई कर दें या m डॉट से मल्टीप्लाई करें if it is flowing. ठीक है, so then it becomes, and otherwise it is joules per kilogram. Every term is actually joules per kilogram. ये small u, ये p over rho, p small नहीं है because P is intensive. Yes, it is not extensive. जब P over rho पे आप divide करते हैं, then it becomes extensive depending upon mass. ठीक है, only P is just a pressure. P divided by rho, then it becomes energy. Intensive property divided by another intensive property, now it becomes extensive. ठीक है. और हाफ वी स्केयर ये हमने तो ऑलरेडी पढ़ा हुआ है, दैट इज काइनेटिक एनर्जी. वी ओनली वी इज नॉट एक्सटेंसिव, बट हाफ वी स्केयर इज एनर्जी. वी स्केयर के जो यूनिट्स हैं वो भी जूल्स पर किलोग्राम है, मैंने लास्ट कहीं क्लास में एक्सप्लेन किया था. ठीक है, सिमिलरली जी जेड. सो ऑल दीज आर एनर्जीज पर यूनिट मास. आप उसे मास से मल्टीप्लाई कर दें, देन इट बिकम्स जूल्स. अगर हम डॉट से मल्टीप्लाई करें, देन इट बिकम्स वॉट्स और किलो वॉट्स. सो नाउ द टोटल अमाउंट ऑफ एनर्जी, जितनी डिस्कशन है यहाँ लिखी भी हुई है. और इन केस ओके, अब मैं आपको बताना, हम कह रहे थे व्हाट इज मैकेनिकल एनर्जी. सो मैकेनिकल एनर्जी इज ओनली दिस वन, P over rho, pressure energy plus kinetic energy plus potential energy. These are pure mechanical forms of energies. U is not mechanical energy. So pump में या टर्बाइन में, हाइड्रोलिक टर्बाइन में, what we have only mechanical forms of energies are changing from inlet to outlet. इंटरनल एनर्जी डू नॉट चेंज. ठीक है, इसलिए हम इसके इफेक्ट को यहाँ स्टडी नहीं करते पंप्स, हाइड्रोलिक पंप्स में और हाइड्रोलिक टर्बाइंस में. इसीलिए आप फ्लूइड मैकेनिक्स में यू स्टडी पंप्स एंड हाइड्रोलिक टर्बाइंस. मैं हाइड्रोलिक टर्बाइन कह रहा हूँ, स्टीम टर्बाइन या गैस टर्बाइन नहीं कह रहा. ठीक है, बिकॉज इन केस ऑफ स्टीम टर्बाइन और गैस टर्बाइन टेम्परेचर आल्सो चेंजेस. ये जिस तरह यहाँ जो हमारे पास केस है, दैट इज अ स्टीम टर्बाइन. स्टीम enters at a higher temperatures, when it leaves इसके प्रेशर एनर्जी भी चेंज हो रही है, इसकी इंटरनल एनर्जी भी चेंज हो रही है. जब आप स्टीम में से एनर्जी एक्सट्रैक्ट करते हैं तो उसका टेम्परेचर भी ड्रॉप करता है, लेकिन आप लिक्विड में से एनर्जी एक्सट्रैक्ट करें तो उसका टेम्परेचर ड्रॉप नहीं करता. ये आपने पंप के केस में भी देखा और हाइड्रोलिक टर्बाइन के केस में भी यही होता है. सो व्हेन देयर इज नो चेंज इन टेम्परेचर, देन इट मींस वी आर ओनली dealing with the mechanical forms of energies. So ये total amount of energy in any substance, और उसमें ये जो तीन parts हैं, P over rho, half V square और G Z, these are pure mechanical forms of energies. अभी मैंने आपको पंप का बताया. So पंप में we have only mechanical forms of energies which are changing from inlet to outlet. But what about compressor? Compressor compressor is used to compress a gas, not liquid. Liquids के लिए हम word use करते हैं pump, gases के लिए we use the term compressor. So ये state 1 है और ये state 2 है. यहाँ पे भी हम work supply कर रहे हैं to the compressor. So what it does, it increases the pressure of a gas. जब गैस का pressure rise करते हैं, what happens to its temperature? जब आप गैस को compress करते हैं, temperature भी change होता है, राइज होता है ना गैस के केस में. सो गैसेस के केस में यू हैव टू इंक्लूड द इफेक्ट ऑफ यू, गैसेस के केस में. सो फॉर द केस ऑफ कंप्रेसर यू कैन नॉट से it is only the mechanical form of energy which is changing. In case of compressor, there is the effect of U is also there. But in case of pump, it is only mechanical forms of energies. In case of compressor, it is mechanical plus thermal also. Similarly, boiler में भी आप देखें, यहाँ पे भी जब आप हीट सप्लाई कर रहे हैं तो टेम्परेचर चेंज हो रहा है या फेज चेंज हो रहा है. अगर टेम्परेचर नहीं भी चेंज हो रहा तो फेज चेंज हो रहा है. सो वो जो फेज चेंज है वो भी ड्यू टू द हीट ट्रांसफर है. सो दैट इज आल्सो द इफेक्ट ऑफ यू इज देयर. ठीक है, कंडेंसर में भी यही है कि यहाँ पे भी या फेज चेंज हो रहा है या टेम्परेचर चेंज हो रहा है बिकॉज हीट इज ट्रांसफर्ड. सो दैट इंक्लूड्स द इफेक्ट ऑफ यू. सो प्योर मैकेनिकल फॉर्म्स ऑफ एनर्जीज आर either in hydraulic pumps or in hydraulic turbines. Compressors में या steam turbines में या gas turbines में, it is not just the mechanical forms of energy, it also includes the effect of internal energy. Okay जी, जो start में question पूछा था student ने pressure energy का, I hope कि pressure energy somehow clear हो गया, क्योंकि जैसे मैंने यहाँ explain किया है book में ऐसा कुछ नहीं लिखा.
Yes, sir.
ठीक है, जितनी डिस्कशन हमने यहाँ की है ये यहाँ सब लिखी भी हुई है, स्लाइड्स पे भी, बुक्स पे भी. सो हियर इज द मैकेनिकल फॉर्म ऑफ एनर्जी. मैकेनिकल एनर्जी ऑफ अ फ्लूइड पर यूनिट मास. इसमें देखिए इंटरनल एनर्जी नहीं लिखी हुई. सो दैट इज द प्योर मैकेनिकल फॉर्म ऑफ एनर्जी. स्मॉल ही है बिकॉज यहाँ आप देखें एवरी टर्म इज पर किलोग्राम, joules per kilogram, joules per kilogram, joules per kilogram. That's why it is represented with small e और subscript में mech लिखा हुआ है. So it means that there is no effect of u we are considering. इसी को आप मल्टीप्लाई करें m डॉट से, सो देन इट बिकम्स कैपिटल E विद डॉट, बिकॉज यहाँ पे डॉट है। मास फ्लो रेट है, सिर्फ मास नहीं है, इट इज किलोग्राम्स पर सेकेंड। सो किलोग्राम्स पर सेकेंड मल्टीप्लाइड जूल्स पर किलोग्राम या किलो जूल्स पर किलोग्राम, देन इट बिकम्स किलोवाट्स। So m dot से हमने multiply कर दिया, that's why we are writing with capital letters and with dot. So m dot into energy per unit mass, ये small e था, ठीक है, rate of mechanical energy of a fluid. और for incompressible substance क्या होते हैं? Pump is used to rise the pressure of liquids, ठीक है। तो जब आप लिक्विड का प्रेशर राइज करते हैं तो व्हाट हैपेंस टू इट्स वॉल्यूम, इसका वॉल्यूम चेंज होता है या नहीं लिक्विड्स के केस में?
यस सर।
होता है, ओके। गैसेस के केस में जब आप गैस को कंप्रेस करें तो उसका वॉल्यूम चेंज होता है?
यस सर।
गैस का तो होता है, लिक्विड का नहीं होता। लिक्विड के केस में जब आप उसे कंप्रेस करें तो उसका वॉल्यूम ड्रॉप नहीं करता, उसका वॉल्यूम फिक्स रहता है। मॉलिक्यूलर लेवल पे ये सम वॉल्यूम चेंजेस, बट कंपेयर टू गैसेस दैट चेंज इन वॉल्यूम इज नेग्लिजिबली स्मॉल, ठीक है। जब आप लिक्विड को पंप करते हैं इसका प्रेशर तो राइज होता है बट इट्स वॉल्यूम डज नॉट चेंज। लिक्विड को कंप्रेस करें ना, किसी भी वेसल में आप लिक्विड लें, अब इसके ऊपर ये फॉर एग्जांपल ये पिस्टन है, इस पिस्टन से इसको कंप्रेस करें लिक्विड को, इट विल नॉट कंप्रेस, आपका पिस्टन मूव नहीं करेगा डाउनवर्ड्स। आप जितना मर्जी फोर्स लगाएं बहुत स्मॉल सी मूवमेंट होगी, नेग्लिजिबल। इसी के कॉरेस्पॉन्डिंग उसी सिलेंडर पिस्टन मैकेनिज्म में इफ यू हैव अ गैस, अब इसे कंप्रेस करें, so we know this gas will compress, so it means the volume of the gas will change but not the liquid. आप उसको प्रेशराइज कर रहे हैं, you are transferring force but it is not changing its volume. So that's why जब वॉल्यूम चेंज नहीं हो रहा तो इट मीन्स कि उसका डेंसिटी भी चेंज नहीं हो रही। डेंसिटी इज मास पर यूनिट वॉल्यूम, उसी फिक्स मास का वॉल्यूम चेंज नहीं हो रहा, मास भी फिक्स्ड, वॉल्यूम भी फिक्स्ड, सो दैट्स व्हाई डेंसिटी आल्सो फिक्स्ड। बट गैस के केस में जब आप गैस को कंप्रेस कर रहे हैं तो उसका वही सेम मास बट वॉल्यूम इज ड्रॉप्ड, ठीक है, जब गैस को कंप्रेस किया, सो दैट्स व्हाई उसकी डेंसिटी इंक्रीज कर गई, राइट। सो इन केस ऑफ लिक्विड्स डेंसिटी डू नॉट चेंज with the change in external pressure, so that's why liquids are known as incompressible fluids. आप fluid mechanics में भी पढ़ेंगे, ठीक है, in detail. So there you are actually dealing with fluids which are incompressible. Here in thermodynamics we shall be mainly discussing with gases, compressible fluids. Right. So incompressible fluid simply means their density remains constant. तो प्रेशर तो चेंज हुआ, ये पंप क्या कर रहा है? पंप बेसिकली इज आप एनर्जी सप्लाई कर रहे हैं इन द फॉर्म ऑफ वर्क, इट रेजेस द प्रेशर ऑफ द फ्लूइड फ्रॉम स्टेट 1 to state 2, but volume does not change, volume stays same, okay, so that type of fluid is known as incompressible and that's why we say its density remains constant. तो अब स्टेट 1 के ऊपर उसकी एनर्जी क्या है, जो टोटल मैकेनिकल फॉर्म ऑफ एनर्जी है, दैट इज P ओवर रो प्लस V स्क्वायर बाय 2 प्लस GZ, ये है स्टेट 1 पे। स्टेट 2 पे क्या होगी, अगेन P ओवर रो, प्रेशर चेंज हो गया P1 से P2 बट डेंसिटी stays same, density same है, so there is no need to write 2, 1 and 2 are equal. प्रेशर चेंज हो गया P से P2, V से V2 एंड GH, यहाँ पे H मैंने नहीं लिखा, सो हाइट भी चेंज हो गई बट डेंसिटी रिमेन्स कॉन्स्टेंट, दैट्स व्हाई इट इज नोन एज इनकम्प्रेसिबल फ्लूइड, ठीक है। सो वी हैव वेरी लिटिल टाइम लेफ्ट, सो मैं यहीं पे स्टॉप करता हूँ। तो इसको आई थिंक रिकॉर्डेड लेक्चर में मैंने ये पोर्शन कवर किया हुआ है, सो आई विल रिपीट again in the physical class, और एग्जाम्पल भी आई थिंक हमने नहीं सॉल्व की रिकॉर्डेड लेक्चर में, सो explain you this slide again, okay, in the physical class. Okay, so we stop here. If you have any question, then ask. Otherwise, I end this class now.
No, sir.